Just let me know if you want to say a few words to start, you want me to start, whatever.
I mean, it's almost 2:30,
Yeah.
but I think people will be filtering in, and if you don't mind, like,
Not at all.
do we have VDOO people? So the way that worked was he told me that we might not necessarily have people from VDOO come, but just at least
I think we've got a total of an hour and a half. I'll probably be speaking for around 15 minutes, and then we'll do some Q&A.
Okay, cool. So I'll see you, what, 3:30?
And so
Yeah.
About that?
you know,
Okay.
it'll be
Cool.
like, they'll go here, and like, hey, also, can you come here? But if not, if they can't come here, then they'll be there, and for us to attend that, we just have to leave the door open for them. So I gotta do that. So I sent some email to some of the other Not sure if it's there.
No, it's, if you're cheating, yes, it is that. But I don't agree with that. I say if you're cheating, large form. Is it always dry first? Large set dry first if you don't cheat. But you know, at least try to do it. Which is a while ago. Did you try? What did you do? Talking about FRQ. She's talking about like FRQ. He was like, it's like someone in history who was like, yeah. Oh, it was about that. Oh, yeah. Okay, yeah. But that's right.
What do you think about that? Well, I agree.
That means try, and then if it doesn't work, you cheat.
Well, I just told him, like, I know mine's probably get March coming. Then we're done.
Is that what you did 45 years ago, CD test?
All of those have gone to me, like, all of those have gone long-term diets. Okay.
Dude, why are you so mean?
Long-term is not diets. All of them have long-term is not diets.
Wow, you have to listen to all the viewers.
Two duos in a party. No, I love you. This is Jordan. It's okay. Alright guys, we might as well get started. Just to let y'all know, we are recording this, so don't. Mr. Sarig, thank you for coming. I don't really have much else to say, so if you want to take it away.
All right. Good afternoon. Thanks for coming. My name is Ido Sarig, and I'll be talking a little bit about how to start an AI startup. Much of my presentation is going to be about starting a startup in general, not AI specific. I will touch on some of the things that might make AI unique or interesting or especially lucrative for starting startups at this moment in time. Completely informal session. If you have questions as I'm speaking, raise your hand. We'll take them. We don't need to wait until the very end. I've prepared about 26 slides, which would take me, I don't know, maybe 50 minutes to talk about if you just let me run through the whole thing. But as I said, I'm happy to take questions throughout. And I'm happy to take this in any direction that interests you. So if there's any topic that we start talking about, you want to know a little bit more about, feel free to ask. We'll delve into it. I've got plenty of time. Thought I'll start by saying a few words about who I am, what I do. This is not to brag, but it is just to give you an idea of what my background is, and that will help you kind of understand what things I can talk to in depth, what things maybe not so much. So I'm currently the managing director of an early stage startup accelerator called Alchemist, which opened up a hub in Memphis last year. The accelerator helps early stage companies get properly set up to raise money from venture capitalists. And by the way, if there's anything that I'm saying here that is not clear, what's an accelerator? What's venture capital? Raise your hand and ask, and I'll be happy to go into that. That is my main background these days. Prior to becoming the managing director of the Memphis Hub for Alchemist, I was and still am a startup coach and mentor with the accelerator. I've been doing that for quite a few years. I've been an advisor and board member at more than 20 early stage startup companies. Some of their logos and names you'll see below. Unless you're coming from their specific domain, I think probably most of these would be unfamiliar to you. You might be more familiar with some of the companies that acquired these companies. So, for example, Cyvera, which was a cybersecurity company, got acquired by Palo Alto Networks. VDOO, which was an IoT security company, got acquired by JFrog. These are some of the bigger names. By way of career, I started out my career as an engineer, writing code in a company called Mercury Interactive. That company invented the field of automated software testing for interactive graphical applications. That's a mouthful. Basically what it means is, back in the day, and I know I'm dating myself here, when Windows, actually it was even before Windows, in the pre-Windows days, there started to appear a whole new class of applications running on personal computers that had interactive input and output through mouse and keyboard, which made testing those applications much more difficult than testing traditional keyboard character-based driven applications. So when I went to school, getting my bachelor's degree in computer engineering, we didn't have those systems. All computer programs at the time were, you wanted to feed input to the system, you typed something on the command line, you received a bunch of text as output. Very easy to test these types of systems because you simply create a data file with the input and then you feed that into the application. And then you read the character-based output and you see if that's what you expected to get. When you're talking about applications that now receive input versus input devices like mice or trackballs or pads, it becomes much more difficult to simulate that input. And when the responses are given, sometimes in graphical format, it's much harder to figure out if what you got is the correct result. And Mercury Interactive found a way to do that. We can go into detail later on about this. Became a very successful company, moved on from that automated software testing into the field of application performance monitoring, moved on from there into IT governance, and finally got acquired by HP for what was then at an astronomical sum of $4.6 billion. Great exit for everybody involved, me included. After that, I moved into what is often called the dark side. The people who actually give money to companies to help them scale up, VCs. And I became a partner with a firm called Thomas Weisel Venture Partners, where I spent a few years investing in enterprise software companies. In between all these things, I was also the top marketing guy at a number of early stage software companies as their CMO or VP of marketing. And in addition to doing that at small companies, I also did that at much larger ones. I was the VP of marketing, of product marketing, and the VP of corporate development at Wind River, which is a company that makes real-time operating systems, which was a wholly owned subsidiary of Intel. And also, I spent some, as I mentioned, some time at Mercury. So that's my background. I can talk at great length about marketing and product marketing. I can talk at great length about the venture world and what it means to start a startup, and that's the topic. Yes, question in the back, thank you.
So you just went through, I sold my business, came into education in a relatively small industry. What you just described was an incredibly dynamic, volatile arc of your career. You got into this thing thinking something. It went through many machinations, acquisitions, and growth. I don't know if anybody understood what you said. I tried to understand it by saying this. You have to anticipate disruption to some degree. Did you think it was going to go like this?
I did not. And first of all, thank you for that question. Second, I will reiterate that if I say something that you do not understand, raise your hand and ask.
I'm saying that to be, I don't know, what you explained really is kind of what's happened to the industry by definition. is growing in front of us, and you have been on that ride for the last 25, 30 years, I'm assuming, with incredible movement.
That is true, and I'll answer your question directly in a two-part way. Does it require anticipation? Does building a successful career require anticipation? I think the answer is sometimes. If you're working in the venture industry, to be a successful venture investor, you absolutely, definitely have to anticipate, predict, and be right in your predictions about what's coming down the pipe. Because if you don't do that, you're going to invest in the wrong companies. That is absolutely correct. As far as my personal career, I wish I could tell you, yes, I had this thing planned out from day one. I knew I need to do this, and I do have friends that are like that. Many of my colleagues started their careers with a very well pre-planned career path. They wanted to be the CEO of an early stage startup company by the age of 35. So in order to do that, they knew that they had to get their MBA beforehand. So there was a 2-year slot where they said, this is where I'm going to go to business school. To get into a good business school, it helps if I have good professional experience. So before business school, I'll put out 2 or 3 years in a software company to get the experience necessary. And in order to get that job, I need to go to a good undergrad school and get a degree in computer engineering or computer software or data science or what have you.
Does that model not really exist?
It exists. Like I said, I have friends that have done that exactly. I'm not one of those. My path was completely different. I don't want to call it haphazard, but somebody who would look at it would not be an unfair characterization. I'll tell you how that career panned out. The only thing that was pre-planned in my career is when I was your age, when I was in high school. I knew I liked computers, and I knew that I wanted to do something in computers when I grow up. What that something was, I didn't really have a good idea. Between high school and going to college, I served in the military for 4 years, so that had to go on hiatus for a moment. And then I went to a good school and started out. I got accepted into a computer software, what was it called? Computer science program. And went through my first year and second year of computer science. And maybe I should have stepped back and give you a little bit of background, personal background. I am an Israeli, born and raised in Israel, hence the military service. As I was going through my sophomore year of computer science, the Israeli high-tech industry hit a major roadblock. Today, if you look at the companies that contribute companies to the NASDAQ, software companies to the NASDAQ, Israel is way up there, I think second only to Canada as far as foreign companies listed on the NASDAQ exchange. Today, it's unthinkable to imagine that Israel didn't have a lively software industry. But back in the day, we're talking 87 or 88 now, there was a major recession in this field. And so as a way to expand my future job prospects, I said computer software is not enough. I need to get the hardware background. So I switched into a program of computer engineering that was done a combination between the Faculty of Computer Science and the Faculty of Electrical Engineering, and gave you the hardware elements as well as the software.
So that diversity in your expectation has served you.
That did.
In this universe of potential. So
Absolutely.
What you're hearing is you don't know what the future is going to bring, and you put yourself in a position around people that are in the game, and you got to be flexible.
That is absolutely true. But beyond that, everything, I went where the current carried me. So I got a job after school when I graduated working for a company that's not even listed here called Daisy Systems, which was a computer-aided design company. Started working there on very boring computer jobs. Won't bore you with the details. I was there for 9 months when the company went under. It declared Chapter 11 bankruptcy. It got acquired by an American company called Intergraph. Intergraph closed down the Israeli R&D center. I was out of a job. Luckily, I found another job with Mercury, which turned out to be an amazing ride. I was there for 14 years, to the point where before coming to Memphis, I spent 20 plus years in Silicon Valley, in the Bay Area. When I finally left Mercury after 14 years, thinking, wow, I'm king of the castle. I've got, under my belt, I've got 14 years of software experience in one of the premier software companies in the Bay Area. People should jump at me. But instead, in the Bay Area, people looked at me and said, what's wrong with you that you spent 14 years at the same company? Because in Silicon Valley, the culture is such that every 2 or 3 years you move on to something new, to expand your horizons, to move to the next shiny object. I didn't do that because, and when I was reflecting on what they told me, why is there something wrong with me? No, the company itself, Mercury, was a completely different, it was the same name, but it was a completely different company for much of that time. When I started there, we were a very early stage startup with a product that wasn't generating revenue. I was employee number 13 there, or 12. You hear all these stories about Silicon Valley companies started in a garage. We were like that. Not in a garage, but we actually were in a residential cottage. Our server room was down in the basement. Engineers worked the ground floor. Management was on the second floor. It was truly a garage-started operation. Very small company. Can talk for hours about the experience of working in such a company if that's of interest. But then we succeeded. We went public. So now we were suddenly a public company, traded on the NASDAQ stock market, grew to be about, at that point, 350 people, expanded from a single product into product lines all around automated software testing, then a new business unit around application performance management, then another business unit around IT governance. And by the time HP acquired us, we were close to $1 billion in revenue. We were 1,400 people. And I was doing different roles. I started out as an engineer. I moved into product marketing. I moved into call it corporate marketing with a regional basis, running marketing for us in Europe. And then I moved into corporate development, doing mergers and acquisitions. So I was doing at least 3, 4, 5 different jobs at a company that was in reality 2 or 3 or 4 different companies. And just I'm going to move through this quickly, or else we won't talk at all about AI. The move to venture was not something I'd planned. It was my last role with Mercury. I was running corporate development. Corporate development is the part of the organization that helps the company buy other companies so it can grow faster by acquiring technologies rather than developing themselves. In that role, I met with a lot of venture capitalists who came to try and sell me their companies. One of these days, this venture firm comes and says, have you ever thought about becoming a VC yourself? And no, up to that point, I hadn't. And tell me a little bit about what it means to be a venture capitalist. And they told me, and I liked it. It seemed like a very interesting job where you meet a lot of energetic, intelligent, relatively young people doing things at the cutting edge of technology. Yeah, I want to be involved with that. And it helps that it pays very well. So I said, yeah, that sounds like something I could do. I spent the next 9 months trying to find a job as a VC because that firm ended up not hiring me. Found a job in VC, spent 4 years with Thomas Weisel Venture Partners. That fund went under, went back into operation. So it was all kind of, I just go with the flow. I didn't plan any of this. Questions about the background, about the VC industry, about what you should do right now to be prepared?
Can you describe how you went from just like a couple products into like multiple different product lines? Like, what was the process of that like?
Good question. So did everybody hear that? Do I need to repeat? What was the process of going from a single product line to multiple product lines? It's mostly market driven. At a certain point in time, you reach, and I'm going to talk a little bit about this in my presentation later on, you reach almost a saturation of the market. There's not much that you can do to grow organically within that particular market because ideally you're the big gorilla in that space and you already have 70% of the market. So anything else is going to have to be by taking market share away from the competition, which is hard to do when their slice is so small. Second part is the market becomes mature, right? If most of the people buy your solution, you don't have any more to sell to. So the impetus was, let's find another growth engine. Application performance management seemed like a very natural extension of the software testing because of the technology involved. I won't go into that unless it really interests you because it's not relevant, but basically we repurposed the same technology that we used to test applications by simulating inputs to now do this testing on a very large scale and simulate massive usage to test application performance under heavy load. These were the days when the internet was just taking off. Web 2.0 was coming into its own. Companies like 800 Flowers moved into the internet. Pets.com, everybody was doing stuff on the internet, and that created completely different challenges for testing performance, because in a typical enterprise application that is deployed on a single campus, you might have a few tens, a few hundreds, maybe a couple thousand users. When you are an online business at peak hours, 1-800-Flowers, the week of Mother's Day, they need to handle tens of millions of customers. And how do you test that? How do you create a situation where you're testing what happens when 10 million users go to your application online at the same time? So that was a natural extension of our previous product line. And then we looked for another growth engine, and IT governance seemed like a good extension, so we did that.
You mentioned that you were with Mercury from when they were really small until they were publicly traded.
Yes.
What were some of the big challenges in scaling such a small company getting that big?
There are many challenges. I would say one of the most difficult challenge is preserving the culture and the DNA of a small company as you grow. As an organization grows, you start to become more bureaucratic. Things that you could do when you were small by just reaching over the cube and tapping your colleague and asking them to compile this or do that. Now there's processes. You have to file a change request. You have to have that change request go through 5 layers of approvals. You have to go to IT to make it could become there is a lot more overhead to everything that you try to do, and that is beyond just the process I described. That is usually, it emanates throughout the organization. You become lethargic. It's like turning a battleship is the idiom often used. Riding a fast motorboat versus turning a battleship. It becomes very, very difficult. I think one of the things that Mercury did exceptionally well was maintain that culture for as long as it was possible. Some of the things that we did right, I think, was a organizational culture of promoting from within whenever possible. Sometimes it's not possible, but giving people a path so that they know it doesn't necessarily end here. And I mean, look at me. I was there 14 years. I was not the only one. There were people who were there longer than me. All right, let's start talking about actually starting a startup and not about me. It's instructive to explore what VCs look for, not because every business that you start necessarily will have to have VC funding. There is certainly a path where you create a lifestyle business that doesn't require more than your initial capital that comes from your pocket or your family's pockets. There might be a business that can thrive on just a small business loan. Not every business needs to have VC money, but usually the ones that scale very quickly and become billion-dollar companies do require other capital, and that capital usually comes from VCs. But even if you don't take money from VCs, the reason I want to focus on this slide is that the things that VCs look for are the things that they think and have empirical evidence to support. These are the things that predict success. Not perfect prediction, right? If it was easy, if it was possible to accurately predict, we'd have a much larger percentage of companies succeed, whereas today the rate is only about 10% of startups actually succeed. But these are good indicators. So it's 3 pillars. It's what's the market, what is the team, what is the product. When I say what is the market, we're talking about how big is it, right? It's not enough that it's big, it should also be growing, because if it's pretty big right now but already has competitors in it, and it's not growing, your slice is going to be smaller. How competitive is it? And this, in AI today, one of the challenges in AI is just about everywhere you put your finger, there's already a handful of companies there. It is extremely, extremely crowded, and you've got to be able to pick out a niche that is not crowded, but at the same time is big enough that would make it attractive. That's not easy. Second element is the team. The team that builds a startup needs to be credible. And credibility can come from two places. Maybe they are successful entrepreneurs who are doing this for the second, third, fourth time. Somebody who's already sold 3 companies successfully, there's a good chance you're going to be able to do that on the 4th one. Somebody who's doing this for the first time is a big risk. In addition to having done this at a other startup, we also look for their domain expertise. If you are a very successful entrepreneur or executive in enterprise software, but now you want to do something completely different. Now you want to do a consumer product for fast food restaurants. Does your expertise from enterprise software translate well into this new domain? Maybe it does, maybe it doesn't. And the third is obviously the product. And some of you might be scratching your heads, why did I mention product only at the very end? I mean, isn't it all about the product? It is absolutely not all about the product. In fact, of all these things, the product is probably the least interesting, because a successful team can pivot the product as needed to find good product market fit, which I'll get to in a second. They can find new technology, they can acquire technology, but they can't acquire a different background for themselves. So what do VCs look for beyond these 3 things? The most important thing that they look for is the thing in the center there, the fit between the product and the market. What is product market fit? Stated simply, it's the situation where you have a product or a service that you sell to a group of people, the market, in a way that satisfies their demand. They have a particular need. Your product meets that need. And it is all about finding that initial product market fit. To try to put it in more tangible terms, let's maybe explore 1 or 2 ideas of what is not a good product market fit. You familiar with the Segway?
Yep.
Yeah, okay. Segway is the classic example of a product. Excellent product here on the bottom. Very deep technology. Very sophisticated mechanical engineering components, gyroscopes that made it self-stabilizing, electric motors that could be promoted as an alternative to fossil fuel-driven vehicles. Questionable quality, I'll give you that, at least in the early models. But on this, top-notch. Total miserable failure in the market because it did not have good product market fit. What do I mean by that? They tried to market it initially as I said earlier, a way for us to reduce traffic congestion on cities and highways, because people would use this instead of driving a car. But they were trying to market this in the US, which has a very, very deep car culture. Trying to get US consumers to switch over from their personal vehicle to something else is a very difficult task. I'm not saying it can't be done. It can be, and we can talk, again, related to AI, about what self-driving cars might do to this market. But at the time, why would I want to give up my car? What problem does the Segway solve? What does it solve that you can't do with, say, a bicycle? A bicycle is also not motor-powered. A bicycle also doesn't create congestion on the streets. It's man-portable. And on top of all that, it cost, when it entered the market, $5,000. Meaning hardly any, that's the price at the time when it was introduced, that was the price of a relatively new used car. So now is, do I want to buy a used Toyota Corolla? Or at the same time, same money, I'll buy this device that I need to learn how to ride, that I can only take myself, not my family. I can't go shopping with it. Very poor product market fit. I'll give you another example of poor product market fit. I'll get to that in a second. Yes? Yes. When I say product, I mean it in a very general, it's whatever you sell. It could be a service. Absolutely, it could be a
What
service.
you said is that people didn't want it.
People didn't want it, and that's the fundamental thing that companies that fail to find good product market fit fail at. They fail to assess the market demand for their specific product. The product might be a very good fit for a different market, but in the market that they're going to, there's no need. And we'll talk about a few more examples down the road. All right, so if these are the things that VCs look for, market, teams, products, let's explore them in relationship to AI. The market opportunity in AI, I think nobody will say today, no investor, no entrepreneur will say there's no market opportunity. It's a huge market. Overall, it's $190 billion. $190 billion is a number that is, we can't put our heads around it. It is a very, very big number. I will try to make it more tangible by saying that when a VC looks at a company and tries to assess the total available market to see if it's going to be a worthwhile investment, the total available market needs to be a couple of billions big. Anything smaller than that means that even if the company becomes a huge success and dominates the market, it's not going to be enough for the VC to make the returns that they need. I have a slide later on the economics of a VC fund that will explain why that is so. But for now, just take my word for it that a VC needs to look at every company that they invest in and believe that it has the potential to become a billion-dollar company. Okay? If it doesn't have that potential, not that they think that all the companies will be billion-dollar companies, but they need to believe that there's a decent chance that they will. If it doesn't, it's not interesting. So if the total market is only $1 billion or less, and no company achieves 100% or anything close to that of the market, it's not interesting. So 190, that's clearly big enough. There's huge market opportunity, and it's broken up into a large number of use cases. AI is being used today in healthcare settings. There are machines, computers that will read an X-ray, a CT scan, a mammogram, and achieve accuracy that is much better than even the most trained radiologist. They don't make mistakes. They don't get tired. They don't get distracted. They just do a better job at that. There is AI being used in finance to identify patterns in your credit card transactions and detect that this one, that's probably fraud because that is completely out of the pattern of your usual purchases. There are use cases in retail. There are use cases in architecture. One of the companies that we recently admitted to the accelerator, their use of AI is for architects who have a plot of land, and there are thousands of possible configurations of what they could build on that in terms of how many single dwellings, high-rise with multiple apartments. It will run through all those combinations and come up with, here's the one that looks to be the most lucrative. This is the one you should design. And there's obviously demand in the market for AI solutions. And no better proof than you guys are here wanting to hear about how do I build an AI solution. So AI, generally speaking, checks off all the boxes that VCs are looking for as far as market. Going back to the discussion about product market fit and finding something that customers really want to. Step number one is identifying a real-world problem that people will be willing to pay money to solve. Okay? And that should be your first step, first focus. Beyond that, you want to pick out, as I said, which area of AI do you want to focus on? There are all sorts of sub-genres within AI. There is natural language processing. If you've ever used, I'm sure you've used, talk to Siri on the phone, natural language processing. Alexa, natural language processing. A very big part of AI research is focused on that. There is computer vision, teaching machines to take signals from sensors like LiDAR, optical signals from cameras and others, and converting them into an understanding of the world. There is robotics. There is even fields that combine all of these together, like self-driving cars, which have both computer vision, NLP, and you being able to tell the nav system where to go, or asking it to play some music. Obviously integrates robotic technologies to control the steering wheel, the braking systems, the engine. So pick out the specialization, and then conduct market research. The market research is around several dimensions. Who are the competitors? You don't want to be in a field that's already dominated by others. Is the market big? Is the market growing? And this leads us into the first question that needs to be answered. Even before coming to product market fit, there is solution problem fit. That's the first step. How are these two different? Solution and problem fit first asks the question, is the pain point that I'm looking to solve even worth solving? Right? Every product that has demand needs to focus on a pain point, identify something that people want solved. But stuff that people want solved doesn't always translate into something that is worth solving. And I'll give you another example related to AI. A couple of days ago, you guys, some of you have LinkedIn profiles? All right. You know what LinkedIn is, though, right? There was a post on LinkedIn from a lady who was lamenting the fact that much of AI today, especially generative AI, is put into creative aspects, creating pictures from prompts, writing text, creating presentations. By the way, this presentation, I used an AI-based tool called Gamma to generate 80% of this presentation automatically. And she was complaining that she doesn't want AI to do those things because those are creative venues that she enjoys doing. She wants AI to be put into things like household chores, doing the laundry, doing dishes. And I got into an online debate with her, pointing out initially that things like doing the laundry or dishes, they are routine, mundane tasks. They don't require intelligence to do. They require automation, which is something else. And somebody else then chimed in and said, well, that's not quite true because, and I said, well, and these two specific things that you're talking about, washing dishes, washing clothes, they've been automated for more than 100 years. It's called a dishwasher and a washing machine. And then somebody else chimed in and said, yes, that's true, but that doesn't solve the whole problem. You still have to load the dishwasher. You still have to fold the laundry. And that's true. But this leads us to the question of, is this a problem worth solving? It turns out you can actually, today, have a robot, a humanoid robot, load a dishwasher for you. Search online, you'll find a number of videos from Samsung showing a humanoid robot picking up plate by plate and inserting them into the dishwasher rack. But if you do your market research and you talk to customers to see if there's demand for something like this, people will tell you, you know, it would be very cool if you gave it to me for free, but even then I'm not sure I would use it because it would take this robot, I don't know, 30 minutes to do a job that I could do in 5. And so I might not even pay you anything for that because I can do it faster. And oh, by the way, I've got kids. Kids will do this for me. I'm not willing to pay anything for that. That is a problem that is not worth solving, at least not with today's technology.
That's a great example, though, of just thinking, you might sound like a good idea, but nobody needs it, nobody wants it.
And like I said, it has been built. And the reason Samsung built it is not because they expect to sell 5 million of these robots. It's basically to show their technological prowess, right? We can do it. We're the best in robotics. The way to answer the question of, is this a problem worth solving, is to separate your solution from the problem and conduct customer interviews that focus just on the problem. Forget how you think it should be solved. Go to 1 million households. Well, maybe not 1 million. That's not practical. Go and do 500 interviews with housewives and ask them, is loading the dishwasher a big problem? Is it a problem at all? Yeah, sure. Would you like this problem solved? I mean, there are solutions that don't involve technology. You could hire a maid. And if you do that research, a likely answer that you're going to get is, yeah, it's a problem, but it's more of a vitamin type problem, right? If you could give me a free maid, I would use the free maid. But if you ask me to pay even maybe $5 for a robot that does it, I might not do it because I don't want to wait 30 minutes for the robot to load the dishwasher or fold the laundry. So you test just a problem, and only after and part of that test would be, yes, it's a big problem. Yes, I absolutely want it solved. Yes, I'm willing to spend good money on that. One of the data points you can collect is how much money you're going to be willing to spend on it. Are you willing to spend $50 on a gadget that loads the dishwasher? Are you willing to spend a Segway like $5,000 for something that loads by having that price point in mind and understanding how big the problem is, you'll get a good sense of, is this a problem worth solving? Am I giving people an aspirin? When you have a splitting headache, you will pay good money to get an aspirin. You won't pay good money to get a vitamin. All right. Once we've convinced ourselves that we have a good problem and solution fit, we move into the product market fit and the product market fit process. It starts with intuition. I think there's a problem. I think I have a good solution. You do the market research. Is it a big market? Is it a growing market? Who are the competitors? You do the validation through customer interviews. You talk to prospects, and most importantly, you listen. The second most common mistake after not doing these interviews is doing these interviews thinking you already know the answer. And as soon as the conversation starts going, you move into sales mode. You told me that loading a dishwasher is problematic. Let me tell you all about my great solution. I'm going to have a humanoid 3-armed robot that will do this without breaking more than one plate a month. The goal of these interviews is not to sell your solution, so you should listen much, much, much more than you talk. Good ratio is, in any customer discussion like that, talk no more than 30% of the time. Prospect, interviewee, should talk 70% or more. As you talk to these prospects, you might be able to segment them into different use cases. Okay? I hate to keep going back to this dishwashing example, but it just lends itself so naturally to one use case might be busy housewives or busy households where 2 parents work. So there's no body to load the dishwasher, and they don't have any kids. So it's one of them who does it. That might be one use case, and they might be interested in the aspect that it gets done automatically, much like the Roomba cleans their floors. The robot will load the dishwasher while they're at work. A different use case might be kids. Again, not for a $5,000 Segway, but if this was an affordable product, kids whose chores it is to load the dishwasher, they say, yeah, I'd like that. It'll enable me to go out and play more video games. For each one of these different use cases, you might create a different offering. Okay? And you fine-tune and iterate your solution until you find traction. Okay? One of the ways to iterate until you find a good solution is a process called the lean startup methodology. If you're serious about starting any sort of company, not just AI, there's a book written by a gentleman called Eric Ries called The Lean Startup. He reflects on his own personal experience of being a not so great entrepreneur, trying a couple of companies that failed, trying to understand why they failed and coming up with a proposed solution. The biggest takeaway from that book is don't build it until you know they want it. Okay? There's a whole lot that you can do in terms of validating the market and finding product market fit without writing a single line of code, without constructing a single hardware device. How does that work? You guys familiar with a company called Groupon? Yeah. All right. Do you know what their initial product was when they were testing out their idea? Their initial product was a web page which said, would you like a group coupon for a couple's massage, a 2-for-1? Fill in your details here. People who were interested went and filled in their details, and then they went and they printed a specially made coupon on a printer that was attached to their machine, and they manually cut it out with scissors, and they put it in an envelope, and they sent it via mail. And they did that for several months until they said, yes, there is a market here. People want to buy group coupons. People want to find out about them on a website like ours, and people are willing to wait some time to get that coupon. And only then they went and they built their entire web-based application, which had a two-sided marketplace where vendors who wanted to offer their stuff could offer the specials, where the coupons didn't have to be printed out but could be emailed to you electronically. But the first product was just that. And actually, for about, I'd say 90% of the web-based ideas for a online business, they could start out that way. Nothing more than a web page that says, if you're interested, fill in your details. That also works for the next stage of the product as you iterate. Let's say you're thinking about adding a particular feature. I'll go back to my own personal experience. I had started with a colleague, a company called Safe Social. The idea there was we both had kids who at the time were just entering middle school, just as the popularity of smartphones meant that every kid in middle school had a smartphone, and every kid in middle school was online on Facebook at the time. Today it's probably TikTok. And we were concerned about cyberbullying. What are the kids exposed to when they're online? The only way to actually keep track of what your kid was posting and what was being posted on his Facebook page was to become one of their friends. Most kids don't want their parents as friends on Facebook, big surprise. So we came up with the idea of being able to, with the kid's consent, be able to have a look at what was being posted on their page without having to be their friend. So as far as their friends are concerned, my parents are completely out of it, but you have complete control. We did this initially for Facebook, and then we were wondering what was coming next. What should we do next after we do Facebook? Should we do Snapchat? Should we do Twitter? Should we do, there wasn't any TikTok at the time, but it was like Snapchat or TikTok or whatever. So we put up a web page that when you sign up for our service, you check off the applications that you're interested in. Mind you, at that time we only had Facebook, but they could check Facebook, they could check Twitter, and they could check Instagram, and they could check Snapchat. And we collected that data, and based on the input, we said, okay, 50% of the people who want Facebook also want Instagram. We're going to do Instagram next. Nobody wanted Twitter. We're not going to even look at that. That works for just about every web-based business. Don't build it until you know that they want it. And the other thing you can do is you can iterate with mock-ups. That's just what I said. You don't actually have to have the product. You just show them what it's going to look like and have them express interest. It's also a process also called manualation. You do it manually before you automate. It comes from, the term comes from, I don't know who coined it exactly, but the way I've seen it illustrated, you guys are probably way too young for this. Anybody in here watch Flintstones on TV ever? So, you know, Flintstones is, the theme there is anachronisms, right? It's supposedly set in the Stone Age, but the people there have all the comforts of home. What's it? Exactly. What's an example of a manualated car? It's two pieces of round rock connected with a pair of timber and a place for you to sit. And if you want to make it go forward, you go like this with your feet. You do it manually. So if I was to today try and design a car, if I was a Stone Age entrepreneur trying to see if the car is a good idea, forget about combustion engines, forget about electric vehicles. I just want to see if the concept has traction. And yeah, I see people sitting on these round rocks and manipulating them with their feet. That's a good idea. I'm going to create that first prototype based on a manual prototype, and then I'm going to figure out how to get the engine to do the work. What time is it? Just making sure we're on track. So the basic process is this. You start with product solution fit. The focus there is to learn from your prospects, and if needed, to pivot your solution to something that really has good fit.
Can I ask a question at this point?
Of course.
be solved on the tip of your mind that you think, that you have thought about since everything he's been saying?
Alpha.
What's that?
Can you fix the alpha?
Okay, we have our own platform by how they get their assignments and their information.
Mm-hmm.
And the original one was actually created, I don't know if Mr. Allman used this, but the original was written by a student.
Wow.
And it was called the Assignment Grabber, and it was excellent. It solved the problem. What are my assignments? And I want to see them. And it was a little bit shaming of people like you that charge a lot of money for all your services, because a kid just went, I wrote this program, and dude, you put in what you needed, and it spit it out, and it was wonderful. And it was adopted for a while in our new platform of how you get your information, but it's been frustrating. It's never been as good as what Roger Chu built back in the day. Very interesting. But the problem was, I got all these classes, I got all these teachers, I have all these assignments. How can I get them in one place to know what they are?
Yep.
Put that aside. Is there something else that you're thinking about the world needs? It's an interesting position, because how do you identify a problem? But that's a great example of, I need this right now, how can I fix it?
And actually, the point that you're making, many entrepreneurs, almost all of them, figure out that there's a problem to be solved based on personal experience.
Okay.
They worked in the industry. They saw the shortcomings of existing solutions. Like you said, there's all these sources of information, but what I want to know is when is my next assignment due?
Right.
It comes from personal experience and an understanding of the existing gaps, and that's why it's rare to find people who make the crossover from one domain to another, because they don't have the expertise in the other domain. It can be done. Some people have, exceptional visionaries have that capability. But I mean, if you want to look at somebody like Elon Musk, he's got his fingers in a number of different pies that are completely different from one another. One is popularizing electric vehicles. Another one is a manned mission to Mars. A third one is the boring company that digs tunnels. He is truly a unique individual that can do this crossover, understand the problems in areas he hasn't worked in before. Most people are not like that. Most people come to the realization that there's a problem by doing their daily job and becoming frustrated and thinking, hey, there's got to be a much better way to do this. All right. Before we move into the next phase, I first of all want to clarify something, a common misconception about ideas. When I was a VC, a lot of times I would meet with entrepreneurs who, before coming to a meeting with me, would say, I want you to sign a non-disclosure agreement. I've got this fantastic idea, but I'm afraid people are going to steal it. I'm afraid you're going to steal it. So it's a separate discussion of why VCs don't do that, but the point is, ideas by themselves are not worth very much. Everybody has ideas. Ideas are a dime a dozen. You guys Seinfeld fans? I am. I'm going to use a couple of examples from Seinfeld.
No, that's my idea. They stole my idea. No, that's my idea. They stole my idea.
Ideas by themselves are not worth very much. There are two very well-known entrepreneurs whose thoughts I want to share with you. One of them is Yossi Vardi. He's an Israeli entrepreneur. He was the funder, the first investor in a company called ICQ, which you probably have never heard of, but it was a precursor to every chat and messaging application that we have today. It was the first online way for people to send text messages between one another. And he has this funny saying, I used to think that ideas are overrated, which is what I just told you. They're a dime a dozen. Now he doesn't think that anymore. Now he thinks they're completely irrelevant. The only thing that matters is execution. And the value of a company is a multiple between the quality of the idea and the quality of the execution. And the execution is by factors of magnitude more important. What does that mean? If you've got the best idea in the world, right, but no ability to execute on it, it's worth almost nothing. It's a $20 company. If you got a so-so idea, but you've got a crack team that can execute on it, that's $1 million company. Okay. I'll leave you with one more example from Seinfeld. Hopefully you can hear this from way up here.
Look at this. They're redoing the Cloud Club. Oh, that restaurant on top of the Chrysler Building? That's a good idea. Of course it's a good idea. It's my idea. I conceived this whole project 2 years ago. Which part? The renovating the restaurant you don't own part, or spending the $200 million you don't have part? See, I come up with these things. I know they're gold, but nothing happens. You know why? No resources, no skill, no talent, no ability, no brains. No.
So that's the point. People have ideas all the time. Some of the ideas are good, some of the ideas are mediocre. But if you can't put them into action because you've got no talent, because you've got no motivation, because you've got no skills, nothing's going to happen from them. The previous snippet I showed from Seinfeld, where it's my idea, in case you're not familiar with that episode, but it relates to my previous slide.
No.
How do I get out of this? Man.
Hi. It's all these meanings.
Where is my presentation? There we go. Relates to this slide. So when he was telling them, that's my idea, they stole my idea. The idea was for a perfume, a cologne that smells like the beach, smells like the ocean. Is that a good idea? I'd say it's a so-so idea. I mean, there's some elements to that. Some people love the smell of the beach, right? The ocean, it evokes memories of, a vacation. But some people might not think it's such a great idea because, as the executive tells them in the next scene, it's a foul smell. That's why people take showers when they come home from the beach. They don't want to smell like the beach. So I'd say that's probably a so-so idea. Some people will like it, some people will not. But if you put it to Calvin Klein, and they put their brilliant marketing team on it that will put the right marketing message around it and why you want to smell like the beach, why you want to feel like you're constantly on vacation, that could be a $10 million company. All right, so we talked about the market. We talked a little bit about the product. Let's talk about the team. A good team needs to have several components to it. If you're building an AI company, you have to have somebody who's an expert in AI, somebody who understands how to build AI models, somebody who understands machine learning, somebody who knows what the fundamental algorithms of AI are. You need to have, beyond the AI experts, you need to have software engineers who will actually build the product. And you probably need to have a business person who will come up with a good go-to-market strategy, figure out how to promote this thing, how to sell it. That all comes down later. Eventually, you will need to have all these people in the team. But when you're starting out, it could be two people. One guy who is the technical guy, who knows how to build that particular AI application that you're looking for, and another one who has a little bit more business acumen, who knows who to go after, who would be the first customers. Now comes the bad news. The bad news is if you're trying to build a company like this, say in Memphis, or even in Nashville, it is hard because 35% of all the AI engineers in the US are not here. They are in the Silicon Valley Bay Area. So what does that mean? That means that if you're thinking big, you're thinking about what the company is going to grow to beyond that first phase when it's just me and my co-founder, you need to educate yourself. You need to be knowledgeable about the technology stack. Does the school offer AI courses? Okay. Let me put my vote in for doing that. There are certain fundamental things that should probably be part of every computer science curriculum today, certainly at the university level, but I'm thinking probably also at the high school level. Do you study any other computer programming languages?
There's computer science.
And what do they study there? C? Java? C? I'd say
It's not controversial to offer that. As a matter of fact, this club may spur that request. And as you do exit interviews, you also, man, I wish I had done. And we hear some I wish I would have done, but you're exactly right, man.
Yeah.
This is
I think Java was probably the right language for maybe 10 years ago. And it's still a very relevant language, and it teaches good fundamentals of computer programming and notions of object-oriented programming. It is by no means a bad language to start with or to learn, and you're not wasting your time in any way by learning Java. But I'd say if you're seeking a career in AI, it is not the language to learn. The language to learn is probably Python, and to a certain extent maybe R. Those would be, I'd say, the two fundamental building blocks or languages that you would need to learn. If you're serious about building AI models, there are two model building tools that you need to become familiar with. It's TensorFlow, it's PyTorch. Beyond that, the infrastructure required to run large-scale web applications, including AI, but not limited to AI, is not something you need to worry about. Today, it's very easy to build many applications using cloud-based resources like AWS, like Google Cloud. That is something that you need to be knowledgeable about, but you don't need to worry about. Say a few words about the basic technologies that you should probably familiarize yourself with them. And if you don't have any particular AI curriculum in the school, it's probably not offered here. I'll have a slide in a second to tell you how you can get started, even if it's not offered in school and not in an expensive way. But basically, we touched upon this in one of the previous slides. There's machine learning, algorithms that help a computer program learn from a particular data set and make predictions based on that data set about what next elements in the set would be like. There's natural language processing, translating human voice into commands that a computer can understand, and then maybe synthesizing a voice response. Computer vision, we talked about that. Robotics, we talked about that. Neural networks are systems that are intended to mimic, simulate the way the neurons in the brain work to really create very complex reasoning processes. Just on the tip of the iceberg in terms of some of the very common algorithms that you will probably learn in any basic course about AI, there are classification and prediction algorithms like k-nearest neighbors, or KNN. KNN is a very powerful but simple algorithm that says, if I'm going to predict what the next element in the set will be like, the best way to predict which groups it belongs to is to see who its nearest neighbors are. We define a metric that measures what that distance is. And if the 3 closest neighbors belong to class A, and only 2 belong to class C, and only 1 belongs to class B, the new dot is probably going to belong to class A because the closest neighbors are all part of A. That simple concept is at the heart of just about every recommendation system that you've experienced. If you go on Amazon and you buy a particular product, at the bottom it says, people who bought this often also bought that. That is KNN at work. Or it's actually some variation of KNN, because KNN has its own limitations in terms of speed and so on. But fundamentally, that's the way it works. If you go on Spotify and you want it to recommend music for you, that's how it works. It looks at how other people who have songs in their playlists that are similar to yours finds the one that is in theirs but not in yours. They're your nearest neighbors. It says you would probably like this as well. Decision trees and random forest. Random forest is just a collection of decision trees. A decision tree is, as its name, you're probably familiar with the decision tree. I'm trying to decide, should I go on a bike ride today? First question is it raining? If it's raining, then 90% of the time I won't go riding, 10% I might go. If it's not raining, is it humid? If it's not raining and not humid, what's the temperature? And so on. You get into a probabilistic leaf at the edge of the tree that says if all these answers are like that, 80% you should go on a bike ride. And random forest is just a generalization of this. You take multiple trees with slightly different weights and you average them, or you take the majority of the decision. So if the school doesn't offer this and you're not already familiar with these languages, how do you educate yourself? Luckily, there are a number of free or near free resources online. I'm personally a big fan of Coursera. Coursera offers a very deep curriculum in everything to do with AI. Very easy to follow. It's taught by leading experts in the field. For example, they've got a deep learning specialization that's being delivered by Andrew Wen, who is one of the world's leading expert on AI. This specialization can be done for as little as $50 a month. They have financial aid available if you qualify. And for most of these courses, they have a week-long trial period, which is completely free. And I've used that week-long free period to, when I had time on my hands, to go through a complete course in 1 week and not pay a cent. So it's doable. Databricks offers a complete generative AI course, absolutely free. Udemy, similar to Coursera, has online courses. There it's not so much a grouping for a specialization, but individual courses. You could go and say, I want to learn Python for AI, $12. How much time do you have, Patrick?
It is 3:34.
And
Said 3:45.
okay. So I'm going to skip over some of these things. And I'll talk a little bit about the VC world, and then I'll open up to just general questions about everything I talked about. And if we don't cover everything, I'll be happy to come back some future date. Let's talk about VCs first, about the VC world. If you're going to get funding for your company, there are all sorts of sources for capital. You could go to family and friends, which is how most people get started. You could maybe take a business loan. You could go to venture capitalists. You could go to angel investors. I want to talk a little bit about why this concept of venture capital even exists. In the old days, before everything became digital and electronic, everything was in a physical world. You had an idea for a company. You're going to be a high-end chocolatier. Going to make gourmet chocolates. You went out. You needed to rent a place to put your chocolate making machine in. You needed to buy the machine. You needed to buy raw materials. You needed to hire an employee or two. What'd you do? You'd go to a bank, or you'd go to the Small Business Commission, and you'd ask for a loan. And the bank would give you the loan with your assets, your physical assets, as collateral. Meaning, if your business fails, like most businesses do, the bank gave you, I don't know, $10,000 to buy the machine. You bought a machine that's worth $8,000. Your business goes under. The bank takes that $8,000 machine, and it didn't lose $10,000. No, it loses $2,000. In the digital world, you can't do that because the assets that the companies have are all intangible. They're all intellectual property. They are software. They are ideas. There's nothing there. So if you say, as most companies do, I need $1 million for my seed round in order to hire engineers to write the code, nobody's going to give you, or no bank is going to give you $1 million to do that, because if your company fails, like 90% will, that $1 million is gone. There's nothing for them to repossess. There might be a handful of laptops. There might be some office furniture. It won't come to even $50,000. They'll be out $1 million. And that's what led to the rise of venture capital. Venture capital are people who said, you know what? We're willing to take that risk. We're willing to risk that 90% of our investments will go bust, because that one investment will repay everything back in spades. Okay? It goes back to this notion of risk versus reward, right? The less risk you take, the less reward you get. If you have $1,000 to invest somewhere, you could put it into a treasury bill. Treasury bill today pays almost 0% interest, but it's also very safe. Unless the US government as a whole goes bankrupt, which is highly unlikely, in 10 years you're going to get your $1,000 back with a little bit of interest. Very little bit. And in fact, there are times when that interest rate is 0. You're just going to get your $1,000 back. And in fact, there are even absurd situations where the interest rate, not in the US, but it's happened in Japan, the interest rate was negative. You're going to give the bank $1,000, they're going to safe keep it for you, and in 10 years you're going to get $950 back. But that $950 is guaranteed. Conversely, as you're willing to take on more risk, invest maybe in public company stocks, you're going to get a bigger return. The average return from the S&P market, annualized over many years, is between 6 and 8%. So there's a much bigger reward here. T-bills pay, say, 0.5%. Stock market pays on average 7%. But there's also risk. Some of those companies might go bankrupt. Their stock price might go down. And all the way at the end, you've got early stage VCs. Early stage VCs and seed stage VCs are willing to take on a huge amount of risk. Like I said, 90% of the companies that they invest in go completely bust. But the 10% that succeed return so much money that the typical VC firm returns much higher returns than the general stock market. That's the general business. I said I will talk earlier about why every VC needs to believe that the company that they invest in is going to be worth $1 billion, and I quickly want to go through the economics of a typical VC fund. A typical VC fund, and there are various sizes of VCs, but the basic math holds for all of them. Let's say we have a $100 million VC fund. That fund will typically invest in about 20 companies out of that $100 million fund. In order for the fund to be attractive to its own investors, the people who give the VCs the money that then they use to invest, they need to have a return that's better than what you could get in the stock market, right? Because you're taking on a larger risk, so you need to promise a bigger reward. So they need to return to their limited partners, their investors, they need to return 2.5 times the capital that the investors gave them. Otherwise, it's not going to be attractive to the investors. In order to do that, the gross returns of the fund need to be 3x what they invested, because there are fees that the VC firm takes. They take 2% every year of the funds that they've been given in order to pay themselves salaries, in order to pay for their operating costs. So if it's a $100 million fund, every year the VC firm that manages that money takes $2 million out of that 100 and pays the VC partners their salary and pays rent and pays whatever operating expenses they have. So over 10 years, that's $20 million. So now they only have $80 million to invest. Okay? Of that $80 million, so let's say they've got 20 companies. Actually, I've got this in my speaker notes. So I'll just go into the speaker notes instead of trying to remember what I had here all before. Hold on a second. Walking you through the math. Or maybe I don't. Forget it. Anyway.
Where's his notes? Or yeah, it's at the bottom.
Do you see it?
Or it's like on the very bottom, the left. Right. You get feedback. It's like in the middle of this.
Ah, there we go. My eyesight's not what it used to be. There we go. All right. All right. So the fund size is 100 million, right? 20 million off the top goes into the management fees of the VCs. In addition, since the VCs are not in it just to make the salary, they're in it for the bigger returns to themselves, they take, if a company has a successful exit, the company is sold or goes public, 20% of the profits go to the VCs. That's called their carry share. All right, so the investors only get 80% of the total profits, and that means that after the management fees, I did this with a $300 million fund. Okay, so $300 million fund is 280. Take a step back. It's a $100 million fund. It needs to return 3x on that to the investor. So it needs to return 300 million. 20 million of that 300 goes to pay the salaries and the operating costs of the VC firm. There's 280 left. And then out of that, the carried interest takes 20% of the profits. Okay, profits are 300 million, right? Minus the 100 million investment. There's 200 million of profits. They take 20% of that. So there's 40. Did I do this right? Excuse me. It's 280 left over 100. Which is 180 in profits. You take 20% of that. That's 36 million that goes back into the VC's pockets and not to the investors. So what's left to return to the investors is 244 million, which is why in order to return 3x, in order to return 2.5x to the investors, you need the fund itself to return 3. That was the big math. Okay, now let's look at what this means in terms of the companies. So I need to return 300 million from this. I invest in 20 companies. For simplicity's sake, let's say I invest in each company the same amount, $10 million. We said that there's 20 companies from 100 million, so $5 million each. The math works out that from every fund, over a large number of funds, I invested in 20 companies. About a third of them will be losers, complete losers. I completely wipe them out. So all the money I put into those 6 or 7 companies is going to be completely gone. About a third of the companies, another 6 or 7, are going to not be wiped out, but not going to return much. They're going to be break even. I put $5 million into you. You got sold for $5 million. Call it even. About a third are going to return 2 to 5x what you invested in them. You do the math. You see that if, based on all of this, you have to have one company that returns the entire fund. Otherwise, you're not going to be able to get to that 300 million. So that's the economics of a typical VC fund, and why going in they need to believe that every company has the potential to be that one winner that's going to return 10x of the fund. So if I've got a $100 million fund, I need to have one company that's going to return $1 billion, or else it's not going to be worth my while. Okay? All right. I have as much time as you guys want, so if you have any more questions, I can spend another 5, 10, 15 minutes answering whatever you have on your mind that we didn't address.
One question. This is less about investing and more about the AI that you talked about. How important would you say it is, and this might be dependent on the role you want to take, how important would you say it is to understand the back end of AI? You talked about KNN, because right now, most models have been written into libraries, and if you want to use them, you just take the library, take a couple of layers, and then modify the layers until you get a result that you want. So how important would it be to understand the back end of those layers and to understand the libraries?
Unless you want to be a developer of KNN-like algorithms, or to improve the performance of KNN, you don't need to worry about it at all. It's very good to have an understanding of how KNN works, because then you have a good notion of what it can be applied to, what it can't be applied to, why it doesn't scale very well with large data sets. But you don't need, if you're asking me, I've got this great idea for an AI company, do I need to be able to write KNN myself? Absolutely not. Just like today, you needn't concern yourself at all. I'll tell you another personal story. My first job interview I was in my senior year of college. I went on my first job interview, and it was a technical interview, and one of the first problems they had me said, go and jot down an implementation of quicksort in whatever language you want, in pseudocode, whatever. I blanked. I mean, I knew how to write. I studied quicksort. I knew how it works. I could not get that. I could not write it properly. I spent 30 minutes staring at a blank page, trying this, that, and this, and that, and that. And finally, I walked out. Needless to say, I didn't get the job. Today, I wouldn't waste my time asking anybody to write quicksort algorithms, because quicksort's been, for decades, it's been implemented in libraries. Same thing with KNN. If somebody is applying for a job as a machine learning specialist and says, yeah, I know all about KNN, Yeah, I'd ask them, explain to me how KNN works. Explain to me why it doesn't scale well. But for you as a entrepreneur starting a company, do you need to know how to code KNN? No, not important.
Okay, so you've been a venture capitalist for a number of years. Of course, this is the million-dollar question with proper execution. But are there any industries or, I guess, the usage groups that maybe are undercrowded, or is there a niche that is underrepresented that you might be able to, off the top of your head, give us?
That's a tough one. Short answer is I'm sure there are. Longer answer is I don't know exactly what they might be. I would do it the other way around. I would tell you what to probably steer clear of right now. I would steer clear of any generative AI idea that is about producing textual output for any marketing. You have to find a specific, a generic one is probably way too crowded. And ChatGPT can probably do 80% of the work for any generic application. You need to find a specific niche. What that niche is, I don't know. I can give you a few examples of things that I've seen. Don't go do that, but there are good examples of people who are probably onto something. I work a lot with logistics and supply chain companies because that's the nature of the Memphis economy. Turns out that filling out customs forms is a very repetitive, menial job that takes a ton of time. Putting an AI, a text-based AI assistant to do something like that, to train it with all the custom forms that there are, pair it up with another system that will monitor changes in regulations about customs and have it automatically fill out customs forms for you, that might be a good niche application. Other questions? Guys, I really enjoyed speaking to you. Like I said, Patrick, if you want to delve in deeper into any one of these or cover some of the slides that I had to skip over, I'll send you the slides, by the way, if you're interested. We can schedule another session.
Thank you.
All right. Thank you, guys. Good luck, by the way.